Question number 47. The EMF, epsilon, and the internal resistance R of the battery is shown where value of EMF is 4.3 volt and internal resistance is 1 ohm respectively. The external resistance is 50 ohm. The resistance of the ammeter and voltmeter are 2 ohm and 200 ohm respectively. Find the readings of the 2 meters. The switch is thrown to the other side. What will be the readings of the 2 meters now? So here this is switch. First, it is connected to point X. So when it is connected to point X, then these two resistances will be in parallel. And then this 2 ohm will be in series. But when this connection goes to point Y, in that case, 50 ohm and 2 ohm resistance will be in series, and then it will be in parallel with 200. So there are two cases. So case one we are going to discuss. So case one, here we have to find out the current through this 2 ohm resistor and potential difference across this 50 ohm resistor. So let's draw the figure here. This is 4.3 volt, and this is 1 ohm resistor. Then this is 50 ohm resistor. This is 2 ohm resistor, and here there is 200 ohm resistor. So situation is simple. Suppose I current is coming out from this battery. So suppose this is I1, then remaining I minus I1 will go to this resistance. So if we consider first loop, so for this purpose, we write 4.3 must be equal to 1 times I, that is I plus I1 times 50 plus 2 times here current I will be there. So 2 times I. So that is 3I plus 50 I1 is equal to 4.3. Suppose this is equation number 1. And if we consider this second loop, so here 50 times I1 minus 200 times I minus I1 equal to 0. So 50 times I1 minus 200 I plus 200 I1 equal to 0, which gives 250 I1 equal to 200 I, or 5 I1 equal to 4 I. Now, if we put this value here in this equation, what do we get? 3I plus 10 times 4I equal to 4.3, which gives 43 I equal to 4.3, which further gives I equal to 0.1 ampere. From here, 5 I1 equal to 4 times 0.1, which will give I1 equal to 0.4 divided by 5, so 0.08 ampere. So since current I passes through this 2 ohm resistor, so reading of ammeter will be 0.1 ampere. And we have to find out the reading of voltmeter. So for this purpose, so reading of voltmeter will be I1 into 50. I1 is 0.08 multiplied by 50. That will be 4 volt. So this is first case. Now let's consider second case. So in second case, as I told you earlier, that this resistance 200 ohm will be in parallel to the series combination of this 50 ohm and 2 ohm. So in this case, this is 200 ohm. So current I is coming from this battery. So this will remain, this is I1, then I minus I1 will pass through this. Now, if we consider first loop, in first loop, what do we get? 4.3 equal to I plus 3I1. So, sorry, not 3, this is 50. So this will become plus 50, 52, 52i1. So we can write it I plus 52 I1. Equation number 5. Now we consider second loop. So in second loop, 52 I1, this current is I1, minus I minus I1 times 200 equal to 0. From where we get 52 I1 minus 200 I plus 200 I1 equal to 0. So it will become 252 I1 equal to 200 I. Or if we divide by 4, 63 I1 equal to 50 I. Now, we have two equations. One equation is this, second equation is this. So we can put the value of either I here. So if we put the value of I, so that would be 4.3 equal to, in place of I, so we can write 63 I1 divided by 50 plus 52 I1. Now, when we simplify, we will get I1 equal to 0.08 ampere. And when we put this value here, so 50 I equal to 63 times 0.08. So this will be equal to 0.14 ampere. Now, the reading of ammeter will be I1. So that is 0.08 ampere. And now PD across, here we have to find out the reading of voltmeter. So we have to find out either this reading of voltmeter will be 200 ohm and then current through it, that is I minus I1, that is 200 into 0.14 minus I1 is 0.08. So it will be 12 volt. So this is answer. Now we go to next question. Next question says a voltmeter of resistance 400 ohm. Here resistance of voltmeter is 400 ohm is used to measure the potential difference across 100 ohm resistor. This is 100 ohm in the circuit shown. What will be the reading of the ammeter, voltmeter? So we have to find out the potential difference across 100 ohm resistor. And what was the potential difference across 100 ohm before the voltmeter was connected? So if there is no voltmeter, then this 100 ohm and 200 ohm will be in series. So let's consider part B first. So part B first will be considered. So here it says I will be equal to 84 divided by 100 plus 200. And reading of voltmeter in that case, yes, what will be the potential difference across 100 ohm before the voltmeter was connected? So reading will be equal to the current times resistance. So reading of voltmeter or voltage, we can say PD, not reading voltage, PD across 100 ohm will be equal to, let's write it like this, 100 ohm will be equal to current times 100. So current will be 84 upon 100 plus 200 into resistance is 100. So if we multiply, so we will get it as 28 volt. This is case number 2. And now we consider case number 1. So for case number 1, it is simple. The situation will be this is 84 and here This is 100 ohm, and this is 200 ohm, and there is a 400 ohm resistor here. These two are in parallel. Now we can evaluate it. So for this purpose, we try to find out current I. So this is I, and suppose current I1 enters here, then I minus I1 will enter here. So we can evaluate, it will be equal to, let's say, equation 84 equal to 200 I plus 100 I1. And in this loop, if we consider, suppose it is number 2, so it is 100 I1 minus 400 I minus I1 equal to 0. That gives 100 I1 minus 400 I plus 400 I1 equal to 0, or 500 I1 equal to 400 I. So 5 I1 equal to 4 I. So we can put this value here. So it will become 84 equal to 200 I plus. We are going to put the value of 5 I1. So 5 I1 means 20 times this. So 20 into 4 I. So this will become 280 I equal to 84. So I will be 84 divided by 280. That is 0.3 ampere. So our concern is to find PD across, here question says PD across 100 ohm resistor. So PD across 100 ohm resistor will be PD across 100 ohm resistor will be current I1. So here we have not evaluated I1. So I1 will be 4I. So I1 equal to 4I divided by 5. So 4 times I is 0.3 divided by 5. So this will be equal to 1.2 divided by 5. So we can multiply this value here. So 1.2 divided by 5 into 100. So this is 20. So this will give 24 volt. So potential difference across 100 ohm resistor will be 24 volt, and across 200 ohm resistor it will be 84 minus potential difference across 100 ohm, that is 24. So it will be 60. So that is our answer. Thank you for watching.